done on the data.gov. And the kind of best thing that came out of that was the gap analysis of what we were missing and what we needed to put into place to meet the risk management plan. And how it relates specifically to Amazon is the way that we've been doing commercial type environments that could take advantage of the load balancing and all the cool stuff that Amazon's got. Some of those things we had to rethink, and we just had to find a different way to do it. So what I really want to talk about, of the diagram that I've put together, I've tried to keep as generic as I possibly can. And the information that I'm going to give you now, I want to keep that generic and really just highlight what you need to be thinking about when you're looking at the gap analysis. And because some of these things kind of hit us from left field. Like I manage the infrastructure group for a hosting company in Canberra. So I had some background in all these requirements, but it was kind of a case of translating some of that knowledge from a traditional virtualized hosting environment, where you've got physical firewalls and routers and the rest of the load balancers, etc., and translating that all into an Amazon environment. So quite a bit of it is kind of having a little bit of a hybrid model of using the types of services that Amazon give you, like the load balancing and the DNS, the Route 53 and that sort of thing, and some of the cool stuff you can do with that. It's a balance of that and just using traditional type, but we mostly stand up Linux environments, but if you've got a background in putting this stuff together for Windows, all that still applies as well. But I think it's important to remember that, just like in virtualized environments, in cloud environments, at the end of the day, you've got an operating system that's running on, a virtualized, system. It doesn't matter whether it's a pizza box in a data center or it's a virtualized server. All the stuff about, like auditing, logging, and security on those services works exactly the same in Amazon as it does anywhere else. And and there's a lot of very mature solutions for load balancing and security and auditing, host intrusion detections, those kinds of things that you can plug into to the Amazon environment and take advantage of that. So what I'll do is I'll roughly so if we look at a scalable Amazon solution, quite frequently what you have is you've got your internet up here. You'll have something like Route 53 that's doing your DNS. And you'll probably have like an elastic load balancer right up the very front there. This is a public facing elastic load balancer. Your Route 53 can dynamically point to this. Now, the reason that that Route 53 is quite an important component where elastic load balancers come in is because you can't use static IP addresses here. These are a dynamic name. So if you're using a C name like www, that's no problem because obviously you can just point it to the name of the load balancer. Where you've got an A record though that needs to be an IP address, then you start getting into grief. So we'll carry on down here. You'll have your load balancer. This is normally going into an auto scale group, and this will have your web front ends here. And these will be talking back to a DB server, and that's really application specific. And and this can be a replicated server. So, and these are in the different availability zones. So the whole point of this diagram is you're really taking advantage of all that scalability and flexibility that Amazon gives you. With this kind of setup, you know, if one AZ completely disappears, your application is still up and running because the elastic load balancer knows to point everything over here. So there's one quite big problem with this setup when you need to be more secure about your application environment. One of the first questions that the IRAPA assessor will ask you, depending on what the requirements of the department are, is how are you logging and how are you auditing access into the environment. Now, anybody that's familiar with the Amazon Web Services will know that it uses security groups to limit access into the environment. So basically a security group is saying allow the whole internet to access port 80 and port 43, and you know, so that security group gets assigned to that web server, and it allows all the web traffic into there. Now, one of the first problems that you face with that is that you don't know what traffic you're not getting into that environment. And one of the security requirements is that again, it depends on the requirements, but usually you will have to log what the drop packets are as well. So straight away you don't know what isn't getting into the service. So this is a traditional kind of commercial setup that we have. The diagram that I've given you on the piece of paper it solves a number of challenges that you have. So the kind of really big key component that we've got in here is a gateway. Okay. So rather than having that load balancer out the front, we've just got a single gateway that's coming in. And basically, and this is, like you'll see in my diagram, that's in a VPC subnet. So the whole entire solution's in a VPC. Okay, now the point of the gateway allows you to do two things, like so it's got a public EIP on it, okay, and that gets around your A-record problem, because now you can point your A-record to that EIP. Now, the reason that this becomes an issue is because most government departments will not let you host their name records. They'll have, like a lot of people tend to be using Verizon to manage the DNS, and they aren't able to point an A record to what's effectively a CNAME. So that fixes that problem. The other thing that you can do, because you're coming into the single gateway, your security group is just a DMZ, so it's allowing all traffic into this gateway server here. The gateway server is now running IP tables. So you have specific rules as to where traffic, so this is also acting as a router. It's got specific rules as to what traffic can get to where. The other thing is using IP tables, you can log all of your traffic, all your drop packets, all of the traffic that you're accepting, where that came from, where it went to, and then you can start doing analysis on the logs. So you can grab your logs of the drop packets and do a risk assessment on, are we getting a particular threat from an IP range, and then you can start taking measures accordingly to that. Now, the next kind of piece of the puzzle that we had to solve, having fixed up this pay record issue, is how do we load balance this? So we want to use multiple AZ zones, and we want to use the elastic load balancing. How do we get around that problem? So we use an internal elastic load balancer. Okay, and this does, so this again, it uses the security groups, and you just assign port 80 and port 443 to that. Now,
so from Amazon's point of view, is that just a standard elastic load balancer that only allows traffic from the
Yeah. So Amazon provide like two types of elastic load balancers. One is a public-facing elastic load balancer that gets a public IP. The internal elastic load balancers just get a local IP for the subnet, for the VPC that it's sitting in. So again, the interesting trick with this is that the IP address may dynamically change for that load balancer. So you can't use IP tables to just forward all your web traffic to that load balancer, because it will only accept an IP address. So after a kind of a bit of a hunt around, I found a Linux utility that's called SOCAT. Now, kind of from the documentation that I've read about it, it looks like a Swiss Army knife of networking. So apart from just doing port forwarding, which is what we're using it for, it does like all sorts of cool stuff. It will take network traffic in and write it to a file. It just, you name it, this thing will do it. And there's some really, if you Google it and look at some of the example configurations, even if you're not using cloud, if you're trying to do something tricky with networking, it's a really good piece of software.
Excuse me, was that SOCAT?
Yeah, SOCAT, yeah. So basically, all the HTTP and HTTPS traffic basically gets routed through SOCAT. It will handle a host name, okay, and it sends all your traffic to the ELB.
And it deals with encrypted traffic and just sends the whole packet.
Exactly, yeah. It doesn't look at the packets, it just forwards them on. Yep. So you've got your SSL cert will be installed on your ELB to enable the port 443. And then after that, you're pretty much back to that other diagram that I had, where you've got your different availability zones. And after that, you can run your auto scale group. And you can pretty much do what you were doing before, as if you had the public-facing elastic load balancer up here. So you can put in all your policies to auto-scale out your environment as it sees load, etc. So that's pretty much the architecture. And the real kind of trick about it was this gateway up the front. Now,
in the drawing,
you're
showing the front ends in one zone, back ends in another zone.
Yeah.
Is it meant to be divided that way, or is it meant to be divided horizontally?
There is an element of least privilege there. So if the front end was compromised, you could only use the...
Yeah, that's right, yeah. So the reason that we've got separate subnets down, these are private subnets. So you need to be inside the local network to be able to access those servers. So the next thing that I'll move on to is kind of touching upon some of the security considerations on access, how you get access to these servers, etc. So one of the things that you'll require is individual logins into all of the servers, again, for editing, for auditing purposes. It's number one, so you can control specifically who has access to what servers, and it's also so that you can audit that access. You can go back through logs, you can see who went in at what time and what did they do. And I've been involved in a couple of instances where in an organisation where there was some fraud that occurred, and luckily we had somebody that was a security person inside the organisation, and it was really insightful and interesting to see the sort of forensics that went on and the types of stuff you could ascertain as to who went where. But for our purposes, what we're really talking about here is controlling who has access to what. So the first thing that you do is on your gate, and just to give this some context, by default when you set up an Amazon instance, it has an EC2 user. So it creates the EC2 user or the Ubuntu user or the whoever it is, depending on what OS you're using. And it also assigns you a key. Now, in a lot of organisations that that haven't given a lot of thought to security, they're probably going to give that access to everybody in the company that needs to get the server. They'll just hand out, like, here's the generic thing. The first biggest problem that you have with that is you've got no idea who went into the server when. And if somebody, emails that key off to a mate and goes, here's the key and here's the username, you've just lost absolutely. You've got no control over your environment. You don't know who's going in there and when or what they're doing. And there's no accountability. If you've got a staff of 5 people and somebody went in there and deleted all the files off and you're using a single key, you're never going to pin down who that specific person was. So the first thing you do is set up the individual users that will, admin users that will actually need admin access either into the gateway or into these other servers. Now, the way that we set this up is when you're looking at security considerations for who has access to what, you kind of have these circles of trust, okay, and you try and keep the circles as small as possible. So it's only people that absolutely need SSH access into that gateway there, or sorry, not SSH so much as like super user, like sudo access. Okay, so the way that we do this is limit down the sudo to either 1 or 2 people. Okay, so it's me and somebody else that's in that very inside circle of trust. So that's your first method of protecting the whole rest of your environment, because if somebody hasn't got sudo on here, they can't add users, they can't create keys, there's a whole bunch of stuff they can't do. And really with the IRAP assessments, it's about assessing what controls have you got in place so that you can control your exposure and your risk. So we've got the individual accounts on here. These all have like individual encrypted SSH keys. So the SSH key actually has a passphrase on it, which is a good practice anyway. Like even if you get that generic EC2 key and you're a single person, you just want to keep using that, I'd probably encrypt it, put a passphrase on it. So even if that key got out in the wild or somebody else got a hold of it, they also need to know what the passphrase is to be able to actually use the key. So then what we do is we set up on all of these other servers, so we might have a DB server, and over here we've got our web servers. Okay, and these again have individual accounts on them for the actual people that would need to get in and do sysadmin type things on there. So when you're coming from the outside world, you first SSH into your gateway server, and then you're sitting on your user account in here, and then you use the key that you've got here and you SSH into your web server or whatever. And again, all of these individual servers, your web servers, your DB servers, or whatever else you're running in your application, you have the DMZ open on them. So with your Amazon security group, you just have one security group, and it says let all traffic, let all traffic from all ports hit the server. And then you're using IP tables on the individual servers with the logging rules against them, so that you can see, because again you need to be able to see what the drop packets are. And your IP rules on these individual servers are only accepting traffic from the local network. So inside our VPC here, this might be like 10.0.0/23 or whatever internal network you're using. So by telling all these servers that they'll only accept traffic from that local address, that means that nobody can reach any of these servers from the outside world. They absolutely have to go through that gateway.
Well, those old internal, I haven't got the practical experience with them.
Yeah.
Those TAN addresses change as well?
Yeah, so like on your, I mean, in the perfect kind of dynamic cloudy world, right, everything should be absolutely dynamic. Okay, so basically and remember that, like in my diagram, these are separate subnets. So way up here, like this will be a really big, IP range. It'll be a /8 or something like that. And then down here, you'll have like, like a /24 or a /23 or whatever. So you can be very specific, you can be broad but specific about what applications will accept traffic from where. So, so the DB server, for example, you can say to that only, like say if you're running MySQL, that's running port 3306. So you can create an IP tables rule on this server to say only accept database connections from the IP range of these two subnets. So the idea is that you're keeping things a little bit open, because obviously the IP addresses of these might be a range of 256 addresses. So you never know what those addresses are going to be. You need to be able to accept traffic from that subnet. But apart from that, you can be specific. Like if you have another subnet out here that's running something else that doesn't need to talk to the DB server, then obviously that doesn't need to accept traffic for it. So it's really about, and this is all done up the front and your architecting level. But if you basically, the general rule of thumb that I've found in security, and I'm not from a security background, this is just stuff I've picked up from working in organisations that have DSD certified gateways, etc. But the basic rule of thumb is don't give access to anything unless it absolutely needs it. So if you abide by that, it kind of makes things like block everything and allow something specific, and it's a good approach to take. And it keeps your configuration quite simple as well. You know, if you've only got 1 or 2 rules that are accepting traffic from very specific locations, then it keeps your life, you know, a lot simpler. So this is a diagram. So on the printed sheet, I've kind of, you know, put some generic type of points to be thinking about. You know what, the actual solutions that you use really come down to that security assessment, like what are the risks and what are you doing to mitigate them. So for most of the environments that we're using, it's okay, for example, to use S3 to do the backups of the service. So, and you know, the thing that I find is, again, if you come back to just a traditional server environment, there's always a way to solve a problem. So if you're in a situation where you can't use S3, then you can always have an instance. You can either have an instance in Amazon that you're using as a backup server, or you can be using off-site backups. And you can still, you know, you could be doing just a minimum of doing, say, SQL dumps, encrypting that file, zipping it up, and then sending that out to somewhere to store it. So, yeah. So one of the other there's a couple of kind of tricks, like hairy things that I've come across in relation to setting up some Amazon stuff that, you know, initially kind of throws you, but it kind of has a simple solution. One in particular that I came across is a huge amount of it is around the ELBs, because that's really where you get all your flexibility from. But there can be tricks for young players that will catch you out. Like, you know, the classic is that you spin up and, I mean, I've been caught out in really stupid ways. Just thought, what a klutz, you know. But one of the most classic ones is you spin up an EC2 instance, and you're waiting for it to come up on the load balancer. Like, this is an instance that you know has been working, and you know, why isn't it coming up? There's 2 places to look. The very first place is obviously check the firewall rules that you've got, if you've got them running on the server, to make sure that it will accept the IP range that the ELB will be running in. The second one to check is the security group. Like, when you're in a VPC, like, I'll explain this, I'll give it some context. One of the things that we do is, when we're just building servers, we don't want the whole world to get to them. So we'll have a security group that just has our office IP on it. So it'll accept all traffic from that office IP, but nowhere else. But of course that won't work if you haven't given this, like, you know, given it the web ports. Then the ELB is never going to be able to reach it because it's firewalled out. Another kind of tricky one is where you've got a pre-production site and you've got an HTTP passworded. So again, the ELB is never going to be able to get to it because it can't, you know, it can't give it the authentication that it needs to be able to check that index, PHP or whatever is serving. So what I've been tending to do is create like a virtual host entry in Apache that just like goes to a directory called status and ELB .html. So that way your whole entire site is still password protected, but the load balancers can actually see that the instances are there. And you might want to be a little bit more elaborate than that. Like you might actually want that to be a PHP script that actually checks that it's got database connectivity and that kind of thing. So those are kind of the broad brushstrokes. So has anybody got any questions? There's probably stuff I haven't covered.
Sure. So ELBs handle their own failover. If one of your gateways goes down or becomes impaired, how do you then failover to save the backup?
Okay, so yeah, that took some clever thinking, because if you're using Route 53, then it's pretty easy, because Route 53 will do a health check on the host that it's going to go to. The way that I've figured out to get around that is to have a separate monitoring server or just separate monitoring that's checking the health of your gateway. And if it finds that it's down, just unassociate the elastic IP. So you either have a step, it really boils down to how fast do you need to switch across. So if your application can afford, a couple of minutes downtime, then, spin up another gateway and just switch the elastic IP over to it. If your application can't afford that kind of downtime, then, have a hot spare that's running there. And again, just, you can use just use a shell script with the CLI commands, which I've put in there. So you disassociate from your failed gateway here and move it across. And if you want to get really sophisticated, like a really good tip that John Hinderburn gave us when we did the architecting course was, even if you're running a single instance, it always makes a lot of sense to put it in an auto scale group, because if the auto scale group detects that that single instance has got unhealthy, it will terminate it and spin up another one. So if you wanted to get fancy with your scripting, you could actually put that gateway in an auto scale group and intelligently work out when it gets unhealthy or when it's been terminated and restarted up, and make sure it has the correct IP address. And if you do a bit of Googling on dynamically assigning elastic IPs, you'll find there's a lot of discussion. There's lots of people have come up with a lot of good ideas for getting around some of these challenges. And that also applies for different parts of your application that kind of need a specific IP. There's ways and means of doing that. Right down to caching. If you look at things like memcache, people have come up with scripts so that if you have an auto scale group that's running memcache servers, it'll actually modify your config. Like if you're running Drupal or something, it will modify your configuration scripts so that they can pick up the new memcache servers as they come and go. So yeah, thank goodness for Google.
At the database layer, you run the database in both the availability zones.
Yeah, we do. I mean, again, depending on what your risk profile is for the project that you've got, the nice, easy solution is to use the Amazon RDS service. The only downside of that is that you've then got the logging and you've got the logging and the auditing issues around it, plus the fact that you're relying on security groups and you can't see what's being bounced away from the security group. You also don't have control over the instance. So you give, so the benefit of RDS is that Amazon take care of patches and updates on your server, and you just give them a maintenance window of when they're going to do that. The downside is if you have a very strict application that where that's not permissible, then you need to be running your own database servers. And the solution, the solution is that you just run a clustered, MySQL. So you've got a master with read-only slaves that will switch over, and Microsoft have similar solutions as well. So, and this is why at the beginning I was kind of talking, don't forget all the tricks that you know from traditional hosting environments. I've seen a lot of instances where a new technology comes along and people seem to have this kind of, blinker mentality that's how we used to do it. This is, how we should be doing it in this new world, and there's nothing in between. And that's just not true. You can take the best of what you know from traditional solutions and apply it to the cloud. And I think that, gateway thing that we put up the front there is a really, good example of that. It's a hell of a lot easier if you can use Amazon tools to do a lot of this stuff. But if you can't, there's definitely ways and means around it. And a lot of the cases, it's just about Googling how have people, solved this problem in the past, and there's plenty of great information and great resources out there for doing it.
Sorry, one question.
Yeah, that's right.
You talked a lot about the need to log all the arriving traffic because that was a DSP requirement. Because it may be in the book, but the disadvantage, of course, is that you receive all the traffic and therefore you're subject to denial of service, and things have to still go through the network and get to the way the server is going to recognise that it's been attacked. Which is a different risk in itself. Was there any consideration of saying, well, we won't bother logging all this traffic because the whole advantage of this is that we won't get all that traffic, therefore it never arrived, therefore we won't bother logging it?
Yeah, the way that I would answer that, and this kind of relates to the question of why don't you just get the whole of Amazon IRAC assist, is it comes down to the individual application and what the risk profile for that application is. You can't have a one-size-fits-all kind of.
I suppose for the IRAPers in the room, the ISM says things like try to log all traffic, everything, every packet, every byte that passes through your machine, and keep it for 7 days. Which can be an awful lot of traffic and isn't necessarily practical. I think that's a should, not a must. The benefit, the reason you would do that is if you're actually going to do something about it. If you're never going to actually do anything about it, you're keeping track of every single attack you've ever suffered. But because attacks on the internet happen all the time, no one ever does anything with them.
So the component that I don't think I put into my diagram here, but the component that you would use to take care of that is a host intrusion detection system. So, the system that we're kind of investigating using is something called OSSEC, and it actually does analysis of your logs, and it will bring out it'll highlight high risks too. The other tool that a lot of sysadmins really like, but you really have to be a sysadmin to like it, is Splunk. Splunk is excellent at analysing logs. So you're quite correct, there's no point just collecting logs for the sake of, collecting them. One of the things that we do for some of the environments we've got is we actually use LogWatch. So some of the things that I haven't touched upon in my document here is setting up messaging so you get automatically notified of when the server has security updates, and you have a process for how you're going to roll them out and what the impact of the application is going to be. The other one is LogWatch is really useful because that'll send you like all the key points that have happened in your logging, and you can quickly just give that a once over. It goes into the ticketing system, you give it a once over in the morning, and I mean when you see a lot of these logs, you kind of know what you're looking for. And Logwatch in particular will highlight things like this as a possible attack. So, but that, that's kind of a whole separate, component. What do you do with the logs when you get them?